Dear students, let us take up a problem on estimation of RCC slab which includes bar bending schedule. Every RCC quantity consists of concrete quantity and steel quantity, and total estimate of RCC work is equal to sum of cost of the concrete and the cost of steel reinforcement. Now let us understand what is schedule of bars or bar bending schedule. The bar bending schedule gives the information of reinforcement in a tabular form about, say, particular size and type of bars. For example, in slab we have short span bars, that is bars provided along the shorter span. And in the case of rectangular slab, we have bars provided along the longer span. So we have cranked bars and we have straight bars, etc. In beam, we have top bars, bottom bars, and stirrups. In columns, we have main vertical bars and ties, and so on. Please understand that the bars are cranked near the support to take negative bending moment. This concept is from RCC design. Size of the bar means the diameter bar, say 8 mm, 10 mm, 12 mm diameter, etc. Bar bending schedule also gives shape of bending with the sketches. You know, the angle of crank is 45 degree and angle of L bend is equal to 90 degree. Normally bars are L bent at ends of the members. Bar bending schedule also gives number of bars of each set. For example, all short span bars in the case of slab are one set, all long span bars are second set, like that. Bar bending schedule also gives length of each bar, weight per meter of the each different bars, and also total weight of steel required for the given RCC member. The RCC member can be a slab, a beam, lintel, column, footing, retaining wall, etc. Let us discuss about cover. You know, all reinforcements are embedded in concrete with a certain cover. The cover safeguards the steel against corrosion or the rust. The cover for slab reinforcement is 15 mm and the end cover for slab reinforcement is equal to 25 mm. Cover for beams, main bars, is equal to 25 mm. More cover for columns is provided, that is equal to 40 mm, and cover for footing is normally 50 mm. The cover is considered in calculating the length of the bars in the RCC members. There are 3 steps involved in the estimation of RCC works. I told you in the beginning that estimation of RCC work includes calculation of cost of concrete and reinforcement. Now, table 1 it gives you the schedule of bars, table 2 gives you the detailed estimate, and table 3 gives you the abstract estimate. The various columns in schedule of bars being serial number, description of bar, diameter, shape, length, numbers, total length, weight per meter, and total weight. So this schedule of bars gives you the total quantity of reinforcing steel used in the member in kilograms. Table of detailed estimate contains the various columns like serial number, description of item, number, length, breadth, depth, quantity, and remarks. Remarks column can be used for minor calculations. And the third column table, that is abstract estimate table, gives you the total cost of construction for that member. It has the columns like number, description of item, quantity, rate in rupees, and amount in rupees. So for the total 3% contingencies and 2% work charge establishment is added to get the total estimate of RCC member. Let us take up the problem. Let me read the problem statement. Estimate the cost of RCC roof slab in CC 1:1.5:3 over a room of internal size 3 meter into 4 meter. Also calculate the quantity of material required. Given thickness of wall is equal to 30 centimeters, slab thickness is equal to 15 centimeter, steel reinforcement, main steel 10 mm diameter at 150 mm center to center, distribution steel 8 mm diameter at 200 mm center to center. Assume local prevailing rates. Solution part. Initially draw the sketch for the problem statement. The slab size, that is the room size, is given. Wall thickness, main steel, distribution steel, crank, etc. are shown in the sketch. The slab given in the question is a 2A slab, as Ly by Lx is less than 2. Therefore, the reinforcements are cranked in both x and y directions. Let us know more about the crank. Bars are cranked near the support and taken at the top of the slab to take up negative bending moment. These cranked parts are tied using extra bars. The cranked bars are also called as bent up bars. Whenever the bar is cranked, some extra length of bar is used compared to straight bar which is without crank. Look at the figure. Angle of crank is equal to 45 degree. In the triangle, the additional length for each crank or each bent up is equal to AC minus BC. Also note that AB is equal to D, where D is equal to overall depth minus top cover minus bottom cover. And BC is also equal to D. By Pythagoras rule, AC square is equal to 2D square, or AC is equal to D root 2. Additional length for one bent up is equal to AC minus BC, that is equal to D root 2 minus D, D into inside bracket root 2 minus 1, that is equal to 0.4 to D, say 0.5 D round off, which means for every crank 0.5 D times extra length is added while calculating length of bar. Please note this. As I said earlier, bars are L bent at ends of member. You can observe that in the sketch for L bent. For every L bent, the additional length required is equal to 0.5 D, where D is equal to overall depth of slab minus top cover minus bottom cover. Next is weight of bar, that is weight per meter of bar. So we use different diameter bars in different members. Normally for slab, the diameter bars used are 8 mm, 10 mm, 12 mm and so. For beams we use 16 mm, and for columns sometimes we use 20 mm bars, 25 mm diameter bars, etc. The diameter bars are expressed as 8 mm, 10 mm, 12 mm and so on. Steel quantity is expressed in kilograms. Weight per meter of bar is calculated as the product of area of cross section bar into length 1 meter into density of steel. The density of steel is equal to 7850 kilogram per meter cube. For example, say diameter of 8 mm, 8 mm is equal to 0.008 meter. The weight per meter of 8 mm bar is calculated as product of pi into 0.008 square by 4, that is pi d square by 4, into length 1 meter into density 7850 kg per meter cube, which works out to 0.39 kg per meter. Similarly, for 10 mm diameter you can calculate, which is works out to 0.62 kg per meter. For 12 mm diameter bars is equal to the weight per meter is equal to 0.89 kg per meter, and for 16 mm diameter bar, the weight per meter is equal to 1.58 kg per meter, which means 1 meter length of 16 mm diameter bars weighs 1.58 kilogram. 1 meter length of 12 mm diameter bar weighs 0.89 kilograms. The calculation part, before we draw the tables for detailed estimate, abstract estimate and schedule of bars, we need to calculate the length and number of different set of bars. For the given slab, there are 4 sets of bars. Set 1 is main short span bars. Set 2 is secondary bars or distribution bars along the long span. Set 3 is extra bars in short direction, and set 4 is extra bars in longer direction. In the problem, 3 meter side is the short side or the short span, and 4 meter side is the longer span. Length of main bar along short span L is equal to, this bar has 2 bends at end and 1 crank. Therefore, its length L is equal to 3.6. That is the outer length of short direction minus 2 end covers. Each end cover is 25 mm plus 2 bends at end plus 1 crank. So that is equal to 3.6 minus 2 times end cover plus 2 times bends plus 1 crank. Total is equal to 3.73 meter. To calculate number of short span bars, understand that the short span bars are provided across long direction and long span bars are provided across short direction. Therefore, while calculating number of short span bars, we consider long span divided by spacing of main bars plus 1, and while calculating number of distribution bars, we consider short span divided by spacing of distribution steel plus 1. The plus 1 is added every time for the end bars. The difference between main bar and extra bar is that the main bars are cranked, whereas extra bars are not cranked. They are straight bars. So the length of extra bars is equal to outer length of the slab minus 2 end covers plus 2 bends. The extra bars are also bent at the ends. Similarly, the length of extra bars in long direction is equal to outer length of the slab in long direction minus 2 end covers plus 2 bends. The calculations are shown in the slide. The schedule of bar, the detailed estimate and the abstract estimate table are shown in this slide. The schedule of bar table gives quantity of steel in kilograms. The detailed estimate table gives the quantity of concrete, and the abstract estimate table gives the total cost. Coming to the schedule of bars, you can find that there are 4 sets of bars and their diameters, shape of bar, length and numbers as per the calculation in the previous slide are entered in the table. Specimen calculation is also shown here. Total length is equal to product of length and numbers. The weight per meter is written, and the total weight is equal to total length into weight per meter. Weight of all different categories of steel are added, and to this 5% of steel is added to take care of wastage and overlaps, and the grand total is calculated. In detailed estimate table, the quantity is the product of number, length, breadth and depth. Quantity of steel is copied from the upper table. In the abstract table, the quantity of items are copied from the detailed estimate table and the rate is considered from analysis of rates, or sometimes will be mentioned in the problem. The rate of concrete is rupees 14,000 per meter cube and rate of steel is equal to rupees 50 per kilograms. Quantity into rate is equal to amount, which means amount is the product of quantity and rate. To the total quantity, add 3% for contingencies and 2% for work charge establishment, and for the problem the grand total is equal to rupees 43,701. This is the end of the problem.